Hello class, this is a video tutorial on trigonometry. In this video we're going to look at how to calculate the value of missing sides using trigonometry. This process goes about in two general steps. The first step is from the information you're given in a triangle, you place it into the correct ratio, sine, cos, or tan, and then we use algebra and algebraic techniques to solve for the missing pronumeral. At any point in the video, you can pause and solve any of these questions if you'd like. And as the video goes along, I'll be solving the questions. Let's take a look at question A as our first example. Here I'm just getting my calculator ready because we'll be needing it later. So let's first place the information that we have in this triangle into the correct ratio. Here we have, from our angle, we have opposites, and we are given the hypotenuse as well, so that's h. Which ratio do we know that uses the opposite and the hypotenuse? Well, if you answered sine, you are correct. So it's sine of 42 degrees is equal to x over 15. At this point, if you don't quite yet remember how to use algebra to solve this, you can watch any of my other videos, or any other video really, on how to solve algebraic equations. But the general idea is we're going to multiply both sides by 15 because of this denominator, which cancels these out, which gives us 15 sine 42 degrees is equal to x. And this is what we'll be inputting into our calculator. So our final answer, just to make it neat, we'll put x on the left. X is equal to this input that we have here, 15 sine 42 degrees equals, and it'll give us a value 10.036. 10.036. And just for this example, I'm going to be rounding these off into 2 decimal place values. Whoops. This will give us 10.04. Since the answer's the question is in millimeters, our final answer should also be in millimeters, and we must indicate that this is in 2 decimal places that we've rounded to. Let's move right along to answer our next question here. Let's take a look. Once again, from our angle, we are given an opposite and a hypotenuse. So opposite and a hypotenuse, once again, that is sine of 15 degrees, 12 minutes is equal to y over 13.2, multiplying by this denominator on both sides. It'll just cancel these out. It'll give us 13.2 sine 15 degrees 12 minutes is equal to y, and we solve for y by inputting it into the calculator. 13.2 sine 15 degrees 12 minutes gives us 3.460, and solving this for 2 decimal places, 3.46 centimeters at 2 decimal places. Moving right along, here we have once again another ratio. We should place this into the correct ratio first. From our angle, we are given the adjacent and the hypotenuse. So that is adjacent and hypotenuse, that is cos of 32.5 degrees is equal to adjacent, which is z, over 20. Multiplying both sides by 20, it'll give us 20 cos 32.5 degrees is equal to z. Z will equal to, inputting into our calculator, 20 cos 32.5 degrees gives us 16.867. Rounding off to 2 decimal places, 16.87 meters at 2 decimal places. Our last example here, you can probably guess the ratio we'll be using, but in any case we'll take a look at what will be given. So K is opposite from our angle, so O, and 30.9 is adjacent from our angle. That must mean we have to use tan of 25 degrees 15 minutes is equal to K over 30.9, multiplying both sides by 30.9, cancels those out. Writing this out in full, we get 30.9 tan 25 degrees 15 minutes is equal to K. So K must be equal to, using our calculator, 30.9 tan 25 degrees 15 minutes. That'll give us 14.573, rounding off to 2 decimal places, 14.57. Since we're increasing in length, our last one will be in kilometers. That's at 2 decimal places. And that's the beginning. Well, this is the first part. Should have wrote that this is the first part of a 2-part series on how to solve the missing sides using trigonometry. Hope to see you in the next one, because it is slightly different and it's best not to confuse the two. Good luck!